Good evening, class 12. Let's continue. We'll talk about electrochemical series. Now, what is an electrochemical series? It's a series where the electrodes are arranged in tabular form in decreasing order of their standard electrode potential or standard reduction potential. Right? So, basically, we'll speak about the applications. First application of the electrochemical series is predicting the nature of anode and cathode. From the value of the E0, that is the standard electrode or reduction potential, we can understand which one is anode and which one is cathode. For example, if I take zinc electrode, its E0 value is 0.76 and copper electrode, E0 value is your 0.34. Now we know in a galvanic cell, your electron flow occurs from anode to cathode and current flow occurs from your cathode to anode. That means cathode is the electrode at higher potential and anode is the electrode at lower potential, right? So we need to know for cathode the electrode potential value will be higher and for anode the electrode potential value will be lower. Okay, so here we can see for zinc it is minus 0.76, for copper it is 0.34. So which one is my anode and which one is my cathode? Obviously the higher one will be my cathode. So 0.34 goes to cathode and your minus 0.76 will be your anode. So whenever zinc and copper is coupled, your copper will serve as cathode and zinc will serve as anode. Okay. Next application is calculation of E0 cell or cell potential. E0 cell is given as, this we have already done, it's given as E0 cathode minus E0 anode. So if we take an example of zinc and copper, that is if I have this Zn2 positive aqueous, this is my notation of a galvanic cell, this is my Sol bridge, and I have Cu2 positive aqueous and then I have Cu solid, okay, the electrode. So this represents my entire cell notation. So from here I can easily understand which is my cathode and which is my anode. Left hand side my anode and right hand side will be my cathode. If this notation is not given, then also we can understand which is my cathode and which is my anode from their values. The higher value of the E0 will go for cathode and the lower value of the E0 will go for anode. Right? So copper value we know it is 0.34 and your zinc value it is minus 0.76. So if I apply them in this formula, what will I get? It is 0.34 minus of minus 0.76. That is equals to 1.1 volt. So this is my E0 cell. Right? That means when zinc and copper is you're coupled, right? Your E0 of the cell is equal to your 1.1 volt. Right? Next we have feasibility of a redox reaction. Feasibility means basically whether the reaction will occur or not. That we can understand from the E0 cell value of redox reaction. Let us take an example when it is better to understand. Zn2 plus Cu addo Cu2 positive plus Zn. So in this particular reaction, Zn2 positive undergoes reduction, Cu undergoes oxidation. That means zinc will act as what? Zinc will act as your cathode and copper will act as anode. And we know what are the E0 values. For zinc it is minus 0.76. For copper it is 0.34 volt. Now we can easily calculate the E0 cell value. E0 cell value equals to E0 cathode minus E0 anode. So here zinc is my cathode, so minus 0.76. Copper is my anode, minus of 0.34. So if I calculate, my E0 cell value will be negative, that is minus 1.1 volt. So we need to remember whenever the E0 cell value is negative, the reaction cannot proceed. This reaction will never occur. The E0 cell value always has to be positive. Whatever be the reaction, whatever be the redox reaction, E0 cell value has to be always positive for a reaction to proceed. If the E0 cell value is not positive, then that reaction will not occur. That means this reaction is not possible. Okay, but this But the reverse reaction is possible. Reverse reaction means what? That means zinc will undergo oxidation to Zn2 plus and Cu2 plus will undergo reduction to Cu. Okay, if I consider the reverse reaction, then my E0 cell value will be your positive and the reaction will easily proceed. Okay, next application, predicting the strength of oxidizing and reducing agent. From the value of the standard electrode potential, we can understand which one is better oxidizing, which one is better reducing agent. So as the value of E0 increases, that is standard electrode potential increases, the tendency of the element to get reduced increases. That means their reducing power, the tendency of the elements to get reduced increases. So their oxidizing power increases. So higher the E0 value, the elements are better oxidizing agents. Now lower the E0 value, the tendency of the element to get oxidized increases. That means what happens? Their reducing power is increasing. So lower the value, the reducing power increases. That means they act as better reducing agents or strong reducing agents. Right? So if you follow the series, the top ones, the ones which are present higher in the series, they act as strong oxidizing agents, while the elements lower in the series, they act as strong reducing agents. Okay. Next, we have the reactivity of the elements. Reactivity of elements. Now, an electrode with negative electrode potential with respect to standard hydrogen electrode will always act as an anode, and an electrode with positive electrode potential with respect to standard hydrogen electrode will act as a cathode. Okay, element which is present lower in the series can displace an element present higher in the series. For example, zinc plus copper sulfate. Zinc is present below copper in the electrochemical series, so zinc can easily displace copper to form zinc sulfate plus C. Right? And the elements which are present below, at the bottom of the series, they are highly electropositive and act as strong reducing agents, and the elements which are present higher in the series, they are highly electronegative and act as strong oxidizing agents. Right? Then, on moving down the series, the reactivity of the metals increases. Right? For example, we have metals like sodium, potassium, calcium. They are so reactive that they react with cold water easily. But if I consider metals like your aluminium, then zinc, then iron, these metals, they do not react with cold water because they are present above sodium, potassium, calcium in the electrochemical series. So they are less reactive compared to them. As a result, they will not react with cold water, but they can react with steam. Okay, but if I consider metals like your copper, silver, they will not react with water in any condition, neither with cold water, nor boiling water, nor steam. Why? Because they are present above hydrogen in the electrochemical series. So they will never react with water. Actually, reaction with water, what is happening? The metal is displacing hydrogen. Right? Here, when sodium, potassium, calcium reacts with cold water, they displace hydrogen from the cold water. Here, when aluminium, zinc, they react with steam. They displace hydrogen from steam. But copper, silver cannot displace hydrogen because they are present above hydrogen in the electrochemical series. So they will not give any reaction. Similarly, the metals which are present below hydrogen in the electrochemical series, they can displace hydrogen from the dilute acids, while the metals which are present above hydrogen in the electrochemical series, they cannot displace hydrogen from their acids. And so these are basically the properties, the reactivity of the elements and the applications of the electrochemical series. One more application we have, about it we'll discuss in the next class, that is determination of equilibrium constant. Determination of equilibrium constant. Equilibrium constant K. We'll do about this in the next class. Okay. So that's a class 12. Thank you.